Okay, so we're going to talk about limits of transcendental functions. So transcendental functions are your e's and your logs and your trig. So in my mind, when I hear the transcendental functions, in my mind, it's the odd guys. It's the non-normal functions, your non-base functions. Okay, if you research the definition of a transcendental function, you'll find its explanation to be a function which transcends, cannot be expressed in terms of algebra. Examples of transcendental functions include exponential, trig, and the inverse functions of both. So, connecting multiple representations of limits, let's talk about analyzing limits of exponential functions. So we're going to be thinking about exponential graphs, growth and decay, and all those shifts that we learned in pre-cal. Recall that an exponential equation are written in the form of a, b to the x plus or minus something, and then plus or minus something on the end. The stuff on the end is your up-down shift. The stuff in your power is your right-left shift. The b is what tells you if you're growth or decay. And the a really just increases your rate of change. Okay, so I'm looking at a. I've got exponential function where my b is 1.5, so I know I'm growth. Just to review, you know that exponential functions always start here. This one's going down 3 and shifted right 1. So there he sits. Asymptote is always 1 below it. So I can ask you what the limit is without giving you the graph and expect you to be able to go do like a chicken scratch graph and evaluate the limit. So if I'm doing the limit as x heads to negative infinity, so that's as x heads to negative infinity, I want to know what y value is headed to, and it's headed to -3, which is that asymptote. It will always get closer to that y value, but it will never cross it. And as x heads to positive infinity, this y is headed up, so the y's are headed to positive infinity. B, I'm headed to negative infinity, so that's this way, and this guy's headed straight up to positive infinity. And as it's headed towards positive infinity, the y value for this guy's headed to his asymptote, which is a 3. Okay. All right, this one has a negative in the front. That's going to flip a Ruski. He's going to flip over his asymptote. And I want the limit as x approaches negative infinity, so we're headed this way. And the y values are going to be headed to his asymptote, which is at 2. And then headed to positive infinity. This guy's headed south to negative infinity. For this one, headed to negative infinity. He's headed south to negative infinity. And to positive infinity, he's headed to the asymptote at 2. It is that simple. Okay, I don't know if you have the top part of this paper, but we're skipping. So if you have this paper, go down to the bottom of that page where it says example 4, and you should pick right up with where I am. I might have taped them together and made a new page for your notes. I don't know. So it may be the top of the back of the first page, or it may be down there at the bottom. I don't know. You'll figure it out. Okay. So now I have a limit and I have no graph, and this would be calculator inactive. So let's see. This is 0.3, so that's decay. The +2 on the end is going to go up 2, and the negative in the front is going to flip. Okay. So he starts there, and we're going to go up 2. So that's going to shift the asymptote to 1 below it. I am decay, but then I flip. Okay, now, if you need to pause and review or do that slower, then feel free. Limit as x approaches negative infinity. Looks like it's going to be negative infinity. Okay. This one's tricky. So this is an E, and E is 2 and some change, and E is always growth, except when there's a negative in the x, or negative on the x in his power, because negative powers flip him, so technically he's 1 over E, so that's 1 over 2 and some change, and that's going to make him smaller than 1, which is decay. I'm going to go down 3. And if you set that equal to 0 and solve it, you're going to see that you're going to go right 1. Okay. So here, and I'm going down 3. 1, 2, 3. Right 1. Asymptote is 1 below it. And decay. Oh, I missed my point. Okay, I'm headed to negative infinity, and the y's are headed to positive infinity. Okay, and if you need me to slow down and go back over some of these graphs, that's fine. But remember, you have a wonderful piece of notes in your pre-cal notebook that go over this for you. So the more you can do on your own, the more class time we have to work on the homework. So if you can look this stuff up on your own, that would be super. It would save us some time. Okay, so if I'm looking at C, I see the negative in the front, that's a flip. I see the 3, that's growth, but then I see the negative on the x. That's going to flip it, make it a 1/3. So now I'm decay. The negative 3 in the back is going to go down 3, and then if you take your power and set it equal to 0 and solve it, you will see that you're going to go right 1, because it's going to end up being a positive 1. So here I am. I'm going to go down 3, right 1. Asymptote is 1 below it. And decay and flip. Okay, decay, but then I need to flip. Ooh. All right, I'm headed to positive infinity. So the y's are headed to the asymptote, which would be negative 3. Okay. This 1/3 is normally decay, but the power has a negative on its x, so now it's growth. There's a flip, and we are up 1. Okay, so up 1, asymptote, growth, but gets flipped. Headed to positive infinity, so he's headed to negative infinity. Okay, all right, so we're skipping E and F, and again, I can't remember if I cut those out of your notes or if they're still there. So if your notes look like this screen, then you're fantastic. If not, then you just need to skip E and F and go right below it. All right, analyzing limits of trig functions. Most of the work you've done with limits at this point have dealt with polynomial or rational functions. When confronted with trig functions, which you will find throughout the course, there are several methods to use. You need to have unit circle in your toolbox. You need to have the graphs of the function in your toolbox, what sine and cosine look like, and tangent and cotangent. Those are the 4 big ones. So to remember to evaluate a limit, don't assume bad things happen where the limit's headed. I mean, most of the time that's true, but don't just assume it. So like this limit, it says theta is headed to pi over 3. Well, I'm plugging a pi over 3 in for both thetas. Well, that gives me a pi over 3 on the bottom and a 2 pi over 3 in my of my cosine. All that's very nice. So I'm going to say cosine of 2 pi over 3 over 2 pi over 3. All right, let's do some unit circle. 2 pi over 3, 1/3, 2/3. That's up, so that's pretty ugly. Quadrant 2. So cosine of that would be a negative 1/2 over 2 pi over 3. Little bojangles. So negative 3 over 4 pi. And make sure that when you write, hold on, I have done something. Oh, sorry. Y'all probably already see it. I don't know why I have a 2 on my pi in the denominator. That's completely my fault. I'm plugging in a pi over 3. 2 is because of that 2. So, all right, so then there's no 2 there, and there's no 2 there. So then there's no 4 there, there's a 2 there. There we go. I told you I was going to make mistakes. So the answer is negative 3 over 2 pi. When you write your answer, make sure I can tell that your pi is in your denominator, not out to the side. Okay, so for B, I'm plugging in a pi over 2. So 3 sine squared of pi over 2, which is the same thing as that. I'm not squaring the pi over 2. I'm finding sine of pi over 2, and then I'm going to square it. Pi over 2 is north, and that's 0, 1. Sine is the y value. 1 squared is 1. So that's a 3. Okay. Just like some polynomial functions where a function value is not defined, yet a limit exists, the same will occur with trig functions. Okay, I'm going to say that again. Make sure your brain wraps around that. Just like some polynomial functions where a function value is not defined, but the limit at that place exists, the same will occur with trig functions. So evaluate by direct substitution. Okay, I'm plugging in a 0. So sine of 0 minus 1 over cosine squared of 0. That's 1, 0. So sine of 0 is 0. Cosine of 0 is 1. 1 squared is 1. I got a negative 1. There you go. Okay, a few thoughts to consider. If you algebraically determine that a function is undefined at a value, does it mean that the limit does not exist? Not true. Can you look at the graph? How do you analyze the limit when no calculator or graph is permitted? We need to use, there they are, the trig identities, and rewrite the function. Okay, I need, let me rephrase that, you need to brush up on your trig identities. So let's review. The three Pythagoreans, sine squared plus cosine squared equals 1. 1 plus tangent squared equals secant squared. 1 plus cotangent squared equals, hold on, cosecant squared. That's not all. Cosecant is 1 over sine. Secant is 1 over cosine. Tangent, yes, it is 1 over cotangent, but it's also sine over cosine. So that takes, let's do cotangent. So that takes the 4 non-sine and cosine guys and puts them in terms of sine and cosine. The reason we like to do that is because I know the graphs and the values of sine and cosine so much better than I do the other 4. Okay, so there's a walk down memory lane. Determining limits using algebraic manipulation. All right, use your new skills. They are not new skills. They are old skills, near and dear to your heart, to evaluate each limit by first rewriting the function and using identities. Okay, so just look at what you're taking the limit of. 2 times cosine times cotangent. Before you go get all fancy, try to just plug in. So 2 times cosine of pi over 2 times cotangent of pi over 2. Now, cotangent of pi over 2 doesn't scare me because tangent and cotangent of the north, south, east, west are either 0 or undefined because it's a whole bunch of ones and zeros. So I'm gonna spin the dice and take this one for a run. Let's see what we got. So this is 1. No. This is 0, 1. Let's get our point right. Let's try that again. 0, 1. Okay. So 2 times cosine of pi over 2 is 0. Sorry. And cotangent of pi over 2, we just need to make sure that he's defined and then let the 0 in. So cotangent is cosine over sine, so that's 0 over 1, which is a 0. So that limit is 0. If that was a tangent, then this guy would be undefined, and this answer would be undefined. Okay, let's try this one. Let's try just plugging in. See what happens. Pi over 4, see, tangent of pi over 4 doesn't scare me. That's just 1. So sine of pi over 4, cosine pi over 4, tangent pi over 4. And if you don't need to write that step, that's fine. Sine of pi over 4 is root 2 over 2. Cosine of pi over 4 is root 2 over 2. And tangent pi over 4 is sine over cosine, which would be 1. And so this is going to equal 2 fourths, which is 1/2. Remember, root of cow times root of cow is a cow. Okay, now when I look at part C and I see the sine times secant, guys, I know that sine times secant, nope, sine times cosecant is a 1 because I know that cosecant is 1 over sine. So I'm not plugging anything into the top because I know that this simplifies to that before I do anything. Now when I plug theta in, I get 1 over 3 pi and I am done. So use your trig identities anytime you'd like. But remember, you have knowledge of the unit circle like, I mean, I have trained you well. You can use that to help you solve these so much more directly. Okay. Later in this course, you'll learn a smooth technique known as L'Hopital's rule. It will be a quicker method for evaluating many functions. But for right now, you don't know that because you don't know how to take a derivative. So you got to memorize. So you need to know these two. Now notice, it's the limit as theta approaches 0. These special limits do not work unless you're headed to 0. So I'm headed to 0. This one is sine of theta over theta. That's a 1. This one's 1 minus cosine of theta over theta, and that's a 0. So memorize. You get no formula sheets on the calc exam. Everything's got to be in your noggin. Okay, so you're tootling along and doing some limits, and you approach this one, and you say, okay, I'm just going to direct substitute. As Ms. Patterson said, I shouldn't be afraid of just direct substitution. But then when you do this, you get a 0 on the bottom, which could just mean it's undefined, but check out the top. Sine of 0 is 0, and 0 times 3 is 0. Now you have 0 over 0, which is indeterminate form. So you are unable to determine the answer. So you learned a whole bunch of fun algebra tricks in the last section, but I'm sitting here with sine and some thetas. There are no trig identities I can use here. Okay, so look, I am knocking on the door of that. Now let me tell you what I have extra. I have extra this 3 and this 2. So watch what I'm going to do. I'm going to use my limit properties, and I'm going to pull those coefficients out. So now I'm here. Okay. Now I am still not that, but I'm dang close. But I need those two things to be the same. Right now he's a 5 theta. I cannot change that. He is inside and of. However, I can change this guy. If I could make him a 5 theta, then they would be the same. Well, guys, that's not in and of. So watch what I'm going to do. I am going to multiply by 5 over 5 because that is the same thing as multiplying by 1. Now watch. I need this 5 to go right there. This 5 I don't want, so I'm going to put him out here with the 3. So I'm going to go 15 over 2, limit, theta approaches 0, of sine of 5 theta over 5 theta. Now, look at what you have. You look at this. That is exactly that. So this whole thing goes to 1. And 15 over 2 times 1 is 15 over 2. So not only do you have to memorize that sucker, but you have to recognize him within a problem when he's not playing his day. That has to be one of the tools in your tool belt. Okay, for B, I can already see I'm going to get a 0 on the bottom. 1 minus cosine of 0 is a 1. Sine of 3 times 0. Sine of 0 is 0. And that gives me 0 over 0, which is indeterminate. Okay, so now I got to be sneaky. This is over a single term. So I can pull this apart. Now I could pull it apart into 3 separate fractions, but I'm kind of seeing this right here and this right here. So here's what I think I'm going to do. I'm going to do the limit, and I'm going to make this one, and then I'm going to do this one. There we go. All right, remember in pre-cal we would do that? We would take something like, I don't know, 2x minus pi over 3, and we would make it 2x over 3 minus pi over 3. We would pull it apart, and I said you can only pull it apart when you have a single term on the bottom. That's what I'm doing. I'm just choosing how I pull it apart, who I pull apart together. Okay, so now I do believe that that is that. Yep, absolutely. So that goes to 0. Okay, now when I look at this, I cannot just plug in a 0 because that's going to give me sine of 0 on the top, which is 0. Plug in a 0 for the bottom, that's a 0. So this one over here is still indeterminate form, but I'm close to that. I need these things to be the same. I cannot give anything to an of because it's inside, but I can give something to that theta. So I'm going to multiply him by 1 in the form of 3 minus 3 over 3. So this 3 is going to go down here, and this 3 is going to come way out here and just kind of chill out. Okay, because now this is that, and that turns into a 1, and 0 plus 3 times 1 is 3. That is fantastic. Okay, so remember how to graph exponential functions. Remember your trig identities. Learn these two limits and be able to manipulate them so that you can use them.